Hello, welcome to Chapter 9, Homework Questions 105 to 110. Question 105. Graph and shade the solution for the inequality below. We have y is less than or equal to x squared plus 2x minus 8. So we're looking to graph the boundary, in this case, curve, x squared plus 2x minus 8. So maybe the first thing we can look at is, can we find the x-intercepts? So 0 is equal to x squared plus 2x minus 8, and that is factorable, so that's x plus 4 and x minus 2, and you can use your generic rectangle to figure that out. And then we'll use our zero product property to find the zeros, which is at x equals negative 4 and x equals 2, so our x-intercept is negative 4, 0 and 2, 0, so we can plot those 2 points. We also now know that the vertex falls in between those two, so our line of symmetry occurs at x equals negative 1, so therefore our vertex is at negative 1 as well. So we're going to plug negative 1 back into the equation for x, so negative 1 squared plus 2 times negative 1 minus 8. This will be 1 minus 2 minus 8. And that would be equal to negative 9. So our vertex is at 1, or negative 1, negative 9. Alright, so that's pretty good. Let's go ahead and get the y-intercept because that's easy to find as well. So the y-intercept, when x is 0, we plug that in. That's just going to cancel, and leave us with negative 8. So we'll plot that point to kind of help us out, and then the point to the left of that is 1 over as well. So that's good enough. That will give us what we need. It is a solid curve because it is equal to. All right, and now we need to test a point to see if we should be shading inside the parabola or outside. So let's go ahead and test the point 0, 0 since it is available to test. And that would be 0 is less than or equal to negative 8 because the x squared and the 2x will cancel. So 0 is not less than negative 8, so we won't shade inside because that's where that point 0, 0 is. We will shade on the outside of the parabola. Question 106. Graph and shade the solution for the system of inequalities below. So it looks like we have two lines here. I'll graph them in different colors just so you can know which one's which. I'll graph the first one in red. We have a y-intercept of negative 2 and a slope of 3/4, so up 3 and over 4. And I'm also going to go down 3 and over 4 a couple of times. This one will be a solid line. It is equal to. And then we can look at this two different ways. We can go ahead and graph the boundary line of the other one and then test one of the 4 regions, or we can shade this region and then the next one and see where they overlap. So we'll kind of do both, and then you can figure out which method you want to use here. So we'll, sorry, I don't know why I'm shading there. Let's go ahead and test a point. So we'll test 0, 0 for the first inequality. That would be 0 is greater than or equal to negative 2. And 0 is greater than or equal to negative 2, so this ordered pair at 0, 0 is true, so that means everything else in that region is true for this inequality. So there's that. We'll do the next one in blue. So that's at plus 3 is the y-intercept, and then negative 1/2 down 1 to the right 2. You can also go up 1 and to the left 2. And this one is a dotted line, because there is no equal sign. And we can once again test 0, 0. That will be below this line, and that gives us 0 is less than 3. And once again, 0 is less than 3, so we would shade in the direction of 0, 0 again, but with the blue line. So I'd be going like this. And so where they overlap, that's what we're looking for, is the solution. So where they overlap is our solution. So you can see that in this region right here is where the overlap is. So that's where we would want to shade everything. And like I said, if you didn't do the shading, you would just test points and then figure out that in this case we tested 0, 0 anyway. So that was the point that satisfied right here, was the point that satisfied both of them as well. So that would work also. So I cleared everything off, and that's where our solution is. Just make sure when you write your answer that we can tell which region is your solution. Question 107. Write the inequality that represents the x values highlighted on each number line below. So on part A, we can see that the 6 is closed, and it's going to the left, so we'd want all values of x that are less than or equal to 6. For B, it's open at 1 and going to the right, so we'd want all values of x that are greater than 1. Now C, it's in between, so we want, we're going to write this one together, not as two separate things, but we want all values of x that are less than 7. But we also want all values of x that are greater than or equal to 2. Okay, so both of these things have to occur. So x is greater than or equal to 2 and x is less than 7. And then on D, same idea, x is less than or equal to -1, but greater than or equal to -3. Okay, and when I'm saying greater than, I'm reading it from the x. So x is less than or equal to -1 and greater than or equal to -3. Question 108. Determine if the following statements are true or false. A, the absolute value of -6, that would be 6. Is 6 less than 4? No, that is false. B, the absolute value of -3 plus 5 would be the absolute value of 2. So the absolute value of 2 is 2 as well. So is 2 greater than 2.5? No, that is not true. That is false. On C, 4 is greater than the absolute value of 0. The absolute value of 0 is 0. So yes, that would be true. And then on D, the absolute value of -4 plus 3, that's the absolute value of -1. Is that greater than 1? Well, is 1 greater than 1? No, that is not true. So that would be false. Question 109. Coach Ron has 15 athletes trying out for 12 openings on the varsity basketball team. As part of the tryout, he has each player run a mile, and Ron records their time and heart rate as they finish. Coach Ron made a scatter plot as follows. So you can see the scatter plot. You can also see that we are provided with the least squared regression line, and we also have the correlation coefficient. The data is off to the right, and we have some more information below. So let's go ahead and read part A. Ron's assistant, Cheryl, believes they can still find something useful in the results. She proposes that if heart rates could be considered the level of effort given, some athletes may stand out as more or less desirable for the team. Cheryl divided the scatter plot into 4 quadrants and put the new labels on the axis. She also labeled each point. She drew the following scatter plot. So Cheryl, Ron's assistant, came over here and kind of created 4 quadrants based on the data that is above, and trying to figure out if there's some way to make some type of correlation or association with this information. And so then on the part A, it does say describe the association to Coach Ron in detail. So instead of typing all this out, I went ahead and just pulled the answer key right here, and you can see on part A, it talks about the data appears randomly scattered. It doesn't seem like there's any correlation between any of this. There's not an association between the heart rate and the mile time. There's apparently no association between the time running a mile and the heart rate, which is what I just said. And then the only 1% of the variation in heart rate can be explained by a linear association with time to run a mile. And that goes back to your correlation coefficient being -0.119. So when you square that, you only get 1%, which is not good. And the least squared regression line is nearly horizontal, and that's why that variation is so small. And there are no outliers. It's very scattered anyways. So that's kind of the description of the association to Coach Ron. Part B, Coach Darrell believes that the further a player is from the center, the more they help or hurt the team. Give specific advice to Coach Ron about players D, F, N, O, and P. So we're looking at these players right here. D, F, N, and O are right next to each other, close, and then P is up here in quadrant 1. So you're just supposed to give Coach Ron some advice based on those things. And so once again, we can kind of read below here as to what we're looking at. So on D, which is in quadrant 3, ran a fast mile but seemed to be giving little effort. This athlete might already be in outstanding physical condition or have an attitude problem. So once again, we are making some assumptions about this based on the time. You can see that the time is quick compared to a lot of them, and the heart rate is low though, but that could mean they're in good shape. F, which is up in quadrant 2 there. So strong run and strong effort keep this player because they got a good time, but their heart rate is up, so they're definitely pushing themselves. N and O, which is in quadrant 4, ran slowly and gave little effort. Along with player M, we don't know these players' potential or motivation. So once again, took them a longer time to run the mile. Heart rate's not up, so it doesn't seem like they are trying very hard. And then P, which is up in quadrant 1, the slowest of the group, but with the highest effort. This player may improve substantially over time. So it took them a long time to run the mile, or longer than the rest of them, but their heart rate's up, so they're definitely trying as they are running the mile. So just, once again, it doesn't have to be those, but just variations to explain each of the players. Question 110. For the Spring Festival, the Math Club is selling rulers for $1 and compasses for $2.50. Part A. While the club would like to sell as many items as they can to raise funds, they need to make at least $15 to break even. At least $15. Write an inequality to represent the situation. Let R equal the number of rulers sold and C equal the number of compasses sold. So they've already written our let statements for us. We're using R for the number of rulers and C for the number of compasses. Knowing that a ruler cost $1, or selling for $1, I should say, and compasses were selling for $2.50, how can we write that inequality to make sure that we make at least $15? So we want to take the amount that a ruler is going to sell for, which is $1, and times it by R. So 1 times R is just R, but I'll put that 1 in there so we can see it, plus $2.50 for every compass that is sold, and this must be at least $15, so it has to be greater than or equal to $15. All right, so that represents the inequality. Part B, school rules state that the club can sell a maximum of 25 items for the festival. Write an inequality for this constraint or limitation. So we can only sell a maximum of 25 items. So the number of rulers plus the number of compasses has to be less than or equal to 25. So we can't sell more than 25 items. All right, so that's done. Part C, graph the inequalities from Part A and B on the same set of axes so that the compasses are represented on the x-axis. So compasses are down here, and the rulers are on the y-axis. Find the region of points that are solutions to each of them. Can this region fall below the x-axis or to the left of the y-axis? Why or why not? So let's go ahead and set this up. We have R plus $2.50 times C is equal to 15. So we're going to write our boundary line, and then we're going to graph it. And then the other one we're going to do is R plus C is equal to 25. So to solve for R, we can subtract 250C from both sides. And remember, R does represent our dependent variable, so that's what we want to solve for if we're trying to put it in slope-intercept form. So negative 2.50C plus 15. So that means our slope is negative 2.5, and our y-intercept is at 15. So I went ahead and labeled my axes. I went ahead and went up by 2 to make sure that this was going to fit on here, hopefully. We have 0, 15 as the y, so 12, 14, 15 would be right here, right in the middle. And then the slope is negative 2.5. So I'm going to go down 2.5 for every 1. Or, if it helps, if I multiply by 2, I can go down 5 for every 2. That might be a little bit easier to do. So let's see here. If I go down 5 and then to the right 2, I'll do that a couple times and then graph the line. So there's my boundary line for that inequality. Now I need to shade. It is a solid line because it is equal to 15, but I need to shade either in one of the regions. So I want to test the point, so I think 0, 0 would be an easy point to test. So I'm going to plug that back into the original. 0 plus 2.5 times 0, so that'd be 0. Is that greater than or equal to 15? Well, no. If they don't sell anything, that's not a good thing. They're not going to make at least $15. So it would be true above that. So I'm not going to do any shading just yet, but we do know it's going to be true in this region. But I'm going to hold off for a second on that. Now, on the next one, r plus c is equal to 25. Once again, if we solve for r, we're going to subtract c, and then we will now graph this line, boundary line, by knowing that the slope is negative 1 and the y-intercept is 25. And so I've graphed the line. The x and y-intercept both are at 25, and if I test the point on this one, I can test once again 0, 0. So is 0 plus 0 going to be less than or equal to 25? Yes, that is true, whereas this one is not. So with the red line, we would shade in the direction of 0. So what's going to happen there? Well, when we tested the point 0, 0, it worked for the r plus the c is 25, but it didn't work for the first one. So this part of the graph down here would not be a solution because it doesn't satisfy both of them. So let's test another point. Let's test it in this region. Let's just do 10, 0. So what if I test the point 10, 0? That would be 10, or that'd be r, hold on. So 10 would be my x or my c, so this would be 0 plus 10 is less than or equal to 25. Well, yes, that is true. So that one works. Over here, if I test the point 10, 0, let's see, let's make sure I plug it in. R is the y, so that would be 0 plus 2.5 times 10. Is that greater than or equal to 15? So this would be 25. Is that greater than or equal to 15? And yes, it is. So if this is a solution here, then that means everything in this region will also be a solution. So all of this represents my solution. And you'll notice that I'm not going below my x-axis, and I'm also not going to the left of my y-axis. And that is intentional because can I have a negative number of rulers or a negative number of compasses? And I can't. So I only shaded the region that makes sense in context to the problem. And so I just answered this question right here. And then what do the points in the solution region represent? And so the answer to part D is something about the solution points represent the possible combinations of the number of rulers and compasses the club can sell based on their constraints. So they have some constraints on the number they can sell, and also they need to at least make $15 to break even, and even more than that to make a profit.